All right, so today is Monday. We just took, I think, the third circles quiz. The second circles quiz was not very good. And the exit ticket that was more relative to the one we just took today was not great as well. So I'm doing a quick review video. This will not cover everything on those quizzes. If you're trying to do a retake, you need to make sure you have a picture of all the practice problems. You'll see them throughout this video. They'll be in the video, which ones you're supposed to do. I'm just trying to cover the main concepts. And I'm going to try to go through everything in 30 minutes. So we'll see if that happens. So here's a circle. We got a blue line and a red line. First thing you need to understand, the blue line is the diameter. The red line is the radius. They both go through the center of the circle. That's the key. Both of those have to go through the center of the circle. The other thing you need to understand is the diameter is 2 times the radius. So the red line, whatever, let's say that was 5. I would multiply that by 2, and I would get 10 for the diameter. Or I would divide the diameter in half and get 5 for the radius. The other thing, which are formulas you get, we did some things with circumference. So there are 2 formulas for circumference. The circumference is the length of the line that is the circle itself is really the way you would say. You wouldn't call it a line because it's technically a bunch of individual points. But if I started on a point on the circle, and if I went all the way around it, and if I could measure a curved line, or if I could cut it at one point and lay it out straight and measure it, that distance right there, that length is the circumference. And it can be in different units, centimeters, inches, meters. It could be in all kind of different measurements depending on how big the circle is. But it's the length of that highlighted green line, basically. Oh, these are the pages 189 to 254. It's basically the whole module on circles. Next. Review. And no circle stuff there. I'm not going to worry about definitions. We'll go over those as we go through some of them. That just was, we said all circles were similar. There's really only one measure of the size of a circle, and that's the radius. So every circle, if we enlarge it or reduce it, will fit right on top of another circle. So all circles are similar. If they have the same radius, then they're the same circle. They're congruent circles, because that's really the only measure of the size of the circle. So if it's the same, then the circles are congruent. Parts of a circle, we said that we have chords. So chords go from one point on a circle across the circle to the other side. The key is the end points, A and B, are on the circle. So actually, the diameter, we said, is also a chord. It just happens to be a chord that goes through the middle of the circle. A radius is not a chord because it doesn't have endpoints that are on both sides of the circle. One of the endpoints of the radius is the center of the circle, so point C. So we'll do another color. So the radius is not a chord. Its endpoints are not on the circle. So those are just definitions you needed to know. Again, we said that the diameter is 1/2 the radius is 1/2 the diameter. You get the circumference formulas on your reference sheet for the EOC. So I gave them to you in class. If you do a quiz where you need the circumference formula, just make sure I give you the sheet. Sometimes I'll just hand you the quiz and not think about it. So we did all those examples. Again, you're just, and some kids still struggled on it, but you're just plugging numbers into a formula. You get the circumference formula. If you need to solve. Yeah, here, I'm just going to leave it there. If you need to solve for a piece of the circle, and it involves either finding the circumference or you are given the circumference and you need to find the radius, then you just use the formula and you just make sure you plug the numbers in the right spot. This was a problem. I'm not going to go through that, but basically you just have to figure out what the radiuses are, do kind of a do what you know kind of thing. So I can't, I don't know how much I can zoom in. I'll try. Oh, you can zoom in a little bit more. So there's a circle. Let's see. There. So again, if I know the diameter, they give me the diameter. Just so, for example, the diameter of M is 20. I'm sorry. Actually, M is 13. Let me hold on. There. L and M are 20 and then 13. So what that means is when it says respectively, the diameter of L is the first number, the diameter of M is the second number. Sometimes I'll write it in the figure. I can't tell you what the EOC is going to do, so you would need to understand that's what that means. The first circle is the first number, second circle, second number. So if I know the diameter of L is 20, that line is 20. And again, you may want to draw a large version of the problem so you have plenty of room. So I now know if that blue line is 20, that red line is 10. And then I can do the opposite with the other circle M. And again, they're named by the center point. So that's why circle L is the blue and red line. So for M, I'm going to try to do another color underneath. If I know M is 13, so the entire line, I'm going to get rid of this in a second, but just to show you that line right there, that's the diameter. That line is 13 units long. Actually, I guess I can leave it there. Well, that means this part from the middle out to the edge is what would that be 6.5. Again, it gets kind of crammed when I'm doing the video, but there's one little segment. Here, I'll do it in pink. Nah, yellow. This segment right here, we don't have a length for. And I guess we don't have a length at this point. I think they tell us QR is 4. Yeah, you can kind of see it over here. QR is 4. So this, let's see what color. Oh, I just had it. Oh, that's so QR. So again, there are points underneath all of this. So from this point, yeah. So from that point to that point where R was, the point R, that's 4. So using all of those numbers, you have to calculate out, I believe, oh yeah, RM is one thing you have to calculate out. And then I forget what's the other thing you have to calculate out. But so you just have to be able to put all this into a figure and figure out what's left. So if I know from L to R would be this point right here. I'm going to go back to black. So from L to R, I know that was what? 10. So if I know that is 10, I know from Q to R. So again, the red line is 10, if you can kind of still see the red line under there. I know from Q to R, which is, I don't really have a color for them. Oh yeah, I do. So the pink line technically is it. It's not a very good spot. Let me see if I can move it a little bit. So from Q to R. Ah, shoot. Is it moving? Oh, what am I moving? Oh, I think I moved. Yeah. So from Q to R. Actually, here, let me redraw it. I think it's, yeah, that was the right one. So from Q to R would actually be from here because point Q was on the circle. So from Q to R is 4, and it just tells us that right here. If I know from L to R is 10, I know from Q to R is 4, well, then I know from L to Q is 6. So that would be the process you would go through. And I think that's the first thing you're supposed to solve for right here, LQ. And then I would kind of do the same thing, only with the other circle. Well, I know that from Q to R is 4, so that number's right here. I know from, I'm going to get rid of some of the stuff I just did. So see, I know from
this point right here to the center of the circle, because that's a radius. That's, we said 6.5. So if I know that's 6.5, I know this one down here is 4. Then I know from R to M, that piece right there has to be 6.5 subtract 4. And there are problems associated with this that you can try. I guess this is one of them. Just did one of them for you. You can go back and try the example if you want. It's the same kind of problem. And again, for those of you that are newer, the problems we do. Oh, hold that thought. Every time I assign, oh, this is driving me crazy. I hate this. Whenever I try to move it around, it doesn't work. There, example 4. Oh boy, let me make sure. No, I'm sorry, example 5. So again, the problems in the book, the examples always match up with the problems that I cited. So for example 5, these were the problems you had to do. Well, if you want to go back and get help, you can go back and look at example 5. You should have that solved out. If not, we solved it out in a different video. All right, so next lesson, that was kind of that same thing. I'm not going to go through that again. So arcs and chords, this was a pretty short lesson. We said, but there were a lot of things you had to memorize and not many of you memorized them. We said if I have an angle, a central angle. Yeah, so a central angle is an angle where the vertex, so this is an angle, this is the vertex. The vertex is the center of the circle. So that's a central angle. We said the measure of that angle is the same as the measure of its arc. And the way you find the arc is you just basically go from the angle. So here's my angle. I'm going to redo it again just to show you this. So here's my angle. Well, that's one of the endpoints that's on the circle. That's one of the endpoints. So the arc is that piece of the circle. An arc is just a piece of the circle, basically. The arc is that piece of the circle in between those two endpoints. That arc corresponds with the central angle, and their measures are the same. They didn't give us a measure, so we'll make it up. Let's say it's 150 degrees. So if angle PQR is 150 degrees, then arc PR is also 150 degrees. That is for a central angle and central angle only. So that was that whole piece of that lesson. I'm not going to do a whole lot more with it. If you add angles together, then they are the same as the arcs added together. So angle, we'll call that 3, angle 1 plus angle 2 plus angle 3 added together would be the measure of that arc. The arcs match the angles, and if we add the angles together, then we get the measure of the arcs added together. And we can go backwards. If we added the arcs together, that would tell us the measure of the angles added together. All right. That was just something I used to do a problem. That was for your exit ticket where you had to solve. So if you knew the circumference, then you would plug in the circumference. So if the circumference is 40, then you would have to solve for the radius or possibly the diameter. I think it was radius. So you would just say, okay, well, I know the circumference. So that's what C stands for, circumference. That is. So if that's 40, if that's what it tells me in the problem, and they ask for the radius, I know the formula for circumference is that one, actually the one I'm pointing to right there, 2 pi r. So that is 2 times pi times the radius. Well, if I want to solve for the radius, I just need to get r all by itself. So I need to divide by 2 or divide by 2. So that gives me 20 equals pi times r. Well, now to get r by itself, I need to divide by pi. Divide by pi. And that would give you r. Whatever number that is, 20 divided by pi. I'm not going to use a calculator. All right, so that's how we did that problem. That was an exit ticket. All right, here's one that I was
really not. So I was surprised at and not super happy that we weren't doing better on these as a group. Some people did okay. I gave you that process right there. We did problems, and you were supposed to do even more problems, but we did problems over and over in class. Every problem was the same. And some of you got the first step, but then not the second, or first two, but then not the third. If you would have practiced, it would have been impossible to forget that, or gotten some help on it. Nobody comes to me for help, so that means to me you understand it. If you need help, you need to ask for help. Go to tutoring, come to me, whatever you need to do. Every problem we did with those central angles followed that process. We figured out what is the percentage of the circle. Oh, I didn't mean to erase all. Save this. Hold that. All right, so we said, what is the percentage of the circle? Oh, what in the world? Again. Delete. Oh, maybe I need to do this. Hold that. One more thing. So what is the percentage of the circle that we are talking about? So if I create an angle that is right here. So again, that's just a tiny bit short of 90 degrees probably. So let's say they would have to tell you like what the measure is in some units. Could be radians, which we've done, could be degrees. I doubt very seriously they're ever going to tell you what the arc is in length. AB, triple C. Again, the steps are the same. I don't care if it's radians. I don't care if it's degrees, whatever we're doing. I don't care if we're trying to find the length. So if I want to know, we'll just do length first. The length of arc AB. Well, I need to go through my steps. First step, what percentage of the circle is this little piece of the pie? Think of it as a pizza, a pie, whatever. What percentage of the circle is this angle? Or since it's a central angle that matches the arc, what percentage of the whole circle is that arc? Well, we know there's 300. Oh, so for percentage, a lot of you didn't know how to find the percentage. Percentage means you take a part, the part they give you, divided by the whole. That's how you find the percentage. And this, they have to be in the same measure, same units, whatever you want to call it, same measure / units. So if they give me degrees, I'm going to erase some of this stuff so you can always go back. Then I need to use the same measure for the whole. Well, what is the whole circle in degrees? Again, same measure. Well, the whole circle in degrees is 360. That will give you the percentage of the circle. I'm not going to do the math on this. You can do it if you want. So that's the percentage of the circle we're talking about. I can tell you right now, though, it's a little bit less than 25%, because 90 degrees would be 25%. 90 divided by 360 is 0.25. And we know 90 degrees is 1/4 of 360. So that'll give me the percentage of the circle. Now I asked you for length, so that's where the next step comes in. It says length, right? If we see the word length, well, I see the word length. So step 2, I'm just going to estimate 23.5%. 23.5% is what we'll say. I don't know what it comes up with. You can do the math on the calculator. I don't have a calculator on me, so I'm just going to guess. So now step 2, if it says length, it says use the circumference. I need to find the circumference. Well, and they would have to give me, they'll normally give you the diameter. I'm just going to use the radius since it's here. And so I'm going to use the formula that is 2 times pi times r. Again, make sure you convert the number they give you, or make sure you use the correct formula based on the number they give you. So I would say, all right, well, 2 times pi times r would be, and again, this is times,
So 2 times, I'm just going to round it. You should use the pi button, but round it. And then R is 10. So that's 31.14 between those two. And then that times 2 is, so circumference is 62.28. That's my circumference. That's the entire circle. That's what circumference is. We went over that earlier in this video. Now, step 3 just says, oh, and I'm going to add something into these steps. These are in different measures or different units. So different units. So it's the percentage times what you're trying to get. So that means times, I'm going to say the new units, the units you're converting to, like these are all different ways to say the same thing. Units you want to find, something like that. So if I said, find this in length, well, length would be the measure of units. Like normally they'll have like a measure of length there, M. So the whole in this case, because again, I'm supposed to be doing the percentage times the whole. I have the percentage. I have the whole in units in circumference and length. So the length means circumference. So I just take 23.5 times, oh, and that's percent. Some of you messed that part up. You didn't hit the percent button, or sometimes you hit the percent button when you shouldn't have. So you need to hit 23.5%, or you could do point, just leave it as a decimal. That's what shows up actually on your calculator when you do that first step anyway. And then so that would be times 62.28. And then if you do it down here, you'll see you get the same thing. So that's times, not point, times 62.28. So that's percentage times the whole when it comes to finding the length. Now, if you have a problem where you're figuring, and I'll do some really fast, where you're figuring out, if you just want to know the percentage, again, we just did that, you should be able to do it. So when you find percentage, you keep the units the same. So if they're giving me degrees, I need to say, what is the whole circle in degrees? Same units. So that would give me the percentage of the circle. Review. Arcs and oh shoot, did we not do here? Hold on, I got to go back and do. I forgot I got to scroll way down to get into some of that stuff. Nope. Nope. Oh, it's way back. Nope. All right, here we go. So let's do one that has like radians or something in it. Here's about as tough as it gets. I'll do the one that's super tough. It's the same steps though. Step 1. What is the percentage of the circle? So I take the part. Well, in this case, they're telling me that's my part. So 3 pi divided by 4. To find the percentage of the circle, I divide it by the whole in same measures. This is radians. We said if it has pi in it, if the measure of the angle or the measure of the arc has pi, it's in radians. So the whole in radians, we said, is 2 pi. If I start at Z and if I go all the way around the circle back to Z, that is 2 pi radians. I'm not going to go over what a radian is in this video. You can go back and watch the other video, but it's similar degrees, 360 degrees, 2 pi radians. So I would divide by 2 pi. That would give me the percentage of the circle. I'm going to just do it in fractions because I don't have calculator on me. So it's 3/8 of the circle. And that kind of looks right. Like if I come over here and I look at it, well, I know half of the circle would be through here, right? That would be half. Well, I just want this part of the circle. Yeah, that looks like it's less than half. 3/8 makes sense. As a percentage, that's 37.5%. Comes out nice and round. So now, do they ask for length? Yes, they ask for length. So I would use the circumference. Find the circumference. I don't know what it is. I don't have a calculator, but you would multiply the radius times 2 times pi, or just the diameter times pi. And again, you get, so in this case, they only give us radius. So we'd say 9 times 2 times pi. And in the third step, we would say 37.5%. Have to use percent button times whatever the circumference was that we figured out in step 2. Now, there was one problem that kind of messed people up. It was these. We've already done step 1 in these problems. They've given us the percentage of the circle. That's what these are. Those are, I mean, it's got a percent sign right there. Those are the percentages of the circle. So we just skipped to step 2 or 3 if it's not about length, which I don't know if it's ever about length. Oh, actually, it is about length. They do want to know. Well, no, I'm sorry. It doesn't say length. So let's talk about that. These do not say length. They just say find arc AD. Find arc AB. That means find just means degrees. I don't care if you, well, you couldn't find length anyway. There's no diameter and there's no radius. So that should be your first thing. There's no way to find the circumference. So if I just want the degrees, they do step 1 for us. They give us the percentage of the circle. So let's say we're doing arc AB. Step 1, what's the percentage of the circle? Well, they give it to us. It's 20%. That's the percentage of the circle. Step 2, that doesn't say length, so we don't need that. So 2, we don't need that. Doesn't say anything about length. Don't need. So now we're on to 3. Here's where you have to use the different measure. Boy, I don't know of any other way. You may just have to memorize this. If they want us to convert the percentage, they don't say anything about radians. They don't say anything about length. The only thing left is degrees. So I would take 20% of the whole, and the whole in degrees is 360 degrees. So 20% of 360 degrees means 20% times 360 degrees. A lot more people miss that than I thought would. Trying to find one more problem I can do. Don't really understand why those are even in there. Oh, they're just adding things together, I think. We didn't do that. We need to. There's another good one. Again, if it says length, all those are about circumference. Oh, here we go. So I want to go from degrees to radians. So here's a good one. These were on the test, by the way, these 2 sections. So you may want to go back and practice those. If I want to go from degrees to radians, you do that process. Step 1, I need to find the percentage of the circle. When I do that, I need to keep the units the same to find the percentage. Well, the part they give me is 120 degrees. Again, the whole would have to be in degrees. So that's my percentage of the circle. That is 1/3 of the circle. Again, when you find the part, or I'm sorry, the percentage, and you do part divided by whole to find percentage, you need to keep the units the same units for that step 1. Some of you tried to put degrees over radians or something like that on the quiz. So now it doesn't say anything about length, so I don't need step 2. Step 3 then is just the percentage times the whole. And it says I added, it's the units we want. So we want radians. So what is the whole in radians? So percentage would be 33.3% or 0.333333. The whole, and again, remember for step 3, it's the units you're trying to find. It's the new units, whatever you need to write in your notes. So times the whole radians, because that's the units we wanted in, and that would give you your answer. So a lot of times, like I said, they're going to have pi left in it. So if you multiply 1/3 times 2 pi, you get that. You can convert it to a decimal if you want. It'd be 0.6666666 times pi would be the final decimal. Or 0.6666666 times pi if you just want to leave pi in it, but still use a decimal. All right, next. Oh, I don't know how much time I have left, not lots. Yeah, about 7 or 8 minutes is all. So I'm gonna get as much as I can done, and then I'll do a part 2. Maybe I'm on my planning, so I don't have limited time. So we just went over all of that. Let's see. Arcs and chords. I think I went over enough of that. Oh no, I didn't. So the theorem was if the arc is the same, then the chords are the same. So these little guys are telling us the arcs are the same. So that means those chords that are associated with the arc, so arc F or ED is associated with arc ED. I'm sorry, line segment ED, chord ED is associated with arc ED. Line segment FG is associated with arc. Just so you know, the arc is not congruent to the chord. Some of you wrote that. The arc and chord are totally different measures. Like we wouldn't say they're congruent. They're not congruent. If I know that the chords are congruent, then the arcs are congruent. You need to memorize the theorems from this chapter. There was one question on the quiz where you just had to memorize all the theorems and just tell me what you knew. Like, here's one of the theorems. I don't even think there was any math on that theorem right there, not on my quiz at least. But you needed to memorize it so you understood what was happening in it. I'm not going to go over that. You can go through and watch the other videos. I'm just going through some of the math problems. There was a problem where you had to do some more challenging math. It involved creating, just tell you, it involved creating a right triangle. If you didn't create a right triangle on the quiz, then you definitely got one piece of one of them wrong. The only way to solve for it was this little piece right here. Only way to solve for that was with a right triangle. You had to understand that in this situation, if we have a radius or it could be a diameter, and it is at a right angle to a chord, then these two lines are congruent. Well, if I know those two lines are congruent, I also was given, I believe, the radius. Actually, no, it wasn't. Huh. Where would our data come from for that? EFG is 120, so that's one. Maybe they're not asking us to solve in this particular problem. Find FG. So again, if these are bisected, then we said these are bisected. So FG is just 60. So maybe this is a pretty easy problem. Oh yeah, EG is just twice. So that was an easy one. That wasn't a hard one. I think the hard one was down here with the rate. Yeah, here's where they did it. So this is the one with that. And we did that in class. So you can go back and watch that. But the key was we knew the radius because they gave us the diameter. So we knew the radius. So that means we knew that radius right there. We know FH is bisected. And I think they tell us FH is 10. So we know this is 5 here. Talking about that line right there is 5. We know the radius is 6 because they tell us here the diameter is 12. So the only way, and I know if that's a right angle to the right of this, then that has to be a right angle. So the only way to solve for EG was to do A squared, B squared, C squared. So that was on there. It was a part of one problem, so you could have still gotten partial credit on that one. I think that's it for arcs and chords. Let's see, king of chord. Tangents, really quickly. I'm just gonna go over a couple things on tangents. Wasn't tons. Is it not moving? There we go. So it had to do with right angles, right triangles. If a line is tangent to a circle, then it is perpendicular to the radius. So that was the theorem you needed. So that's really the only theorem you needed for most of the problems. If a line is tangent, it is perpendicular to the radius. So that basically created some right triangles. So you had to do a bunch of A squared, B squared, C squared stuff again. What it boiled down to, if you want to know if it's tangent, which is one of the questions on the quiz, then you would just solve and see if it's a right triangle. So we can't do it in that one, but there was a problem somewhere above. If you have all three sides of that triangle, pretty thick. So if I said that's 3, that's 4, that whole side is 5. Oh, just really quickly, if they only write the number out here, then that means that that's only this part of the triangle. This would be 3, so you'd have to add those together. And I think that's normally the way they're going to do it. But let's say that's not the case, and they wanted to say that the whole line was 5. That whole line was 5. Either they would write it really big, or more likely they would do this and show you that that whole thing was 5. So I'm going to leave it as 5 because that just makes my math easy. So if I want to know, is this green line tangent to the circle, I have to solve a squared, b squared, c squared and see if this is a right triangle. If this is a right triangle, the red, blue, and green lines, then yes, that line is tangent. That's the only way it can happen. A tangent line has to be at a right angle, which would mean this would have to be a right triangle. So if I do a squared, b squared, c squared, I get 3 squared plus 4 squared equals 5 squared, which, yes, if you do the math, that is a right triangle. So if that is a right triangle, that means, yes, that is a right angle. So if that is a right angle, then the green line has to be a tangent line. The only way it can be at a right angle is if it is tangent to the radius of the circle or the diameter of the circle. And then the only other thing really that I'm going to go over in this video was this problem. If we have a point outside of the circle and you draw in 2 tangent lines, we said those 2 tangent lines have to be congruent. And you would have to be told those lines are tangent. So that's the bell. That's all the time I have. You can go back and watch the video on that problem. Or if you just remember, 2 tangent lines are congruent. So you'd wind up setting the little equations equal in that case. I'll probably do part 2 to this in more detail on the later stuff.